Welcome to Decarbonizing Today, a deep dive into the Edmonton metro region's role in addressing the global climate crisis. In this episode, we have your Edmonton Global host, Amanda Sparks, here with John McDougall, the CEO of SynBioBlox Innovations. Can you tell us a little bit about yourself, John?
Sure. I'm a longstanding Edmontonian. Our family's been here since 1879. So we got involved in economic development right from the get-go and have continued. And the most recent venture really is SynBioBlox Innovations, which is a synthetic biology company that essentially is taken on the mission of massive transformation of greenhouse gases into valuable products, but using biology.
That's interesting. When I think about biology, I of course think about the human body, and then adding synthetic into that doesn't really click in my mind. How does biology become synthetic, and then how do you use that to capture carbon?
Well, your analogy is kind of interesting, first of all, because I'm going to come at it right from where you posed. So if someone does a kidney transplant, does that make them synthetic?
I would say no.
Yeah, so that's exactly what we do. We essentially transplant elements from one organism to another in order to get them to do things properly or more effectively with better performance, better productivity, that kind of thing. And what we've been able to demonstrate with synthetic biology, which means we can now essentially more readily identify what we might want to cut and paste, the kidneys we want to transform, if you like. We're able to essentially design to purpose. So we can say, what's the emission? So is it CO2? Is it methane? Is it whatever? And what's the product we want? Is it cosmetic? Is it a aviation fuel? And then basically design an organism digitally that has the wherewithal to do that. Then we create, with synthetic biology, create it by taking things from other organisms, basically, that will help it do that, and put them together and hopefully achieve success.
Okay. So you basically just take your little body, your organism, you add an extra kidney here, an extra leg there, so that it can produce what you want it to produce at the end.
We do two things. You look at simplifying it. So what we're interested in is it just focuses on what we want. So you try to get rid of the things it doesn't need just to survive. So you want a very efficient organism. So you minimize in one sense and you add in the other sense, right? So ultimately I get something that is really focused on what I want it to do and just works really hard to do it.
Okay, that's very interesting. And that seems like a very technical start to a company. Where did the inspiration to start using that kind of technology come from?
Well, it begins because essentially humankind is all about biology, right? We eat biological things. We interact with biological things. We use everything we do pretty much, is biologically based. So that means that as we are expanding in population, we're spewing out biological things like greenhouse gases or whatever. If you're going to deal with that problem as the population rises, then you have to turn around and say, well, maybe the best solution is actually biology, because nature does that, right? Does it all the time. The problem is it doesn't do it very efficiently in terms of the load that we're imposing on it. Once upon a time, before the Industrial Revolution, the world was in balance, right? But now we start to turn things on with the Industrial Revolution. We start to build factories and we start consuming much more energy, and we do it in different forms, and we reach in. Ultimately, we start into the automobile, we start shipping and aircraft, and we're flying things around. So when we do that, and at the same time we multiply the population by 8 times, we end up with all of the results just overwhelming nature. Some years ago, we recognized that. And actually, I'll tell you a funny story, because today happens to be my parents' anniversary, or would have been if they were still alive. But my dad came up in the 1930s with a beautiful diagram that I stumbled over a few years ago, which was all about the carbon cycle. And it was amazing. And he obviously was thinking about, hey, what's happening to the world and so on. So I was really inspired by that when I found it. But we had also concluded that biology was going to be the salvation because it's the most logical way to go. We'd started when I was with the Alberta Research Council, actually, years ago, to try to grow algae, which are, they're a nice organism. They make, you can make them, heavy on fats or on carbohydrates or on sugars or whatever. The challenge is the footprint is enormous. So if we were to solve Canada's greenhouse gas problem, for example, and chew up 750 million tons a year, we'd take a good chunk of the province to do it. And I don't think people would like that very much. So we said, okay, not on. I went off and did some other things, but one of the fellows, Quinn, that I'd worked with, came back when I retired, quote unquote, and said, it's time, John, because things have changed. And he was right. What's changed? We have synthetic biology now. We've sequenced the genome on all kinds of organisms. So that allows us to manipulate. The hardware and software has really advanced. So everybody knows about NVIDIA these days and the chips. So we've got what would have been called a few years ago 2 supercomputers sitting on our desktop because of those chips, right?
Yeah.
And we've got software like artificial intelligence, machine learning capabilities because of the chips and the massive amounts of data there are to work on that allow us to really understand things in ways we never, ever could have, even 2 or 3 years ago. So we put all of this together now, and we can produce these amazing results. So our first organism took us about 15 months to design and another 3 or 4 months to actually accomplish. Doing it in the old traditional ways would have taken 15 or 20 years, would have been trial and error after trial and error, probably would have cost $100 million. It just wasn't workable. Yeah. But now it is. And so now it's more about if we can imagine it, we can do it. And with the tools that we've been able to build and put together, we have ways of helping us visualize the possibilities so that we can advance much more quickly and cost effectively.
So you really started using Edmonton's excellence in AI as kind of the push to start this.
Edmonton excellence in AI means there are people around here who understand what we're trying to do, which is good. And they're teaching and training people. In these fields, which is good. It's nice to be in a place that's recognized, but you also need a place that can support the bioinformatics piece. So that's more classical digital tools, not what we would normally call AI or ML, but the digital tools of model building and all that kind of thing. And then we need, of course, the science and engineering skills that can work into the genetics and the bioprocessing side. So unfortunately, we have all of those things in Edmonton.
Yeah.
Where we're most short is on the bioinformatics and genetics people who want to play in a manufacturing space because they tend to go towards health rather than the manufacturing side.
Yes, to kind of change gears a little bit. Why is it so critical that we stop viewing waste as being an end product and really something that we can use more?
Well, we've all seen the pictures, right? First of all, because there's lots of the waste, the bio waste that is very visible, the plastic bags and the islands in the ocean and things by the side of the road and the changing climate, the weather patterns. There's all kinds of visible effects which are clearly being driven by the waste and the volume of waste that we produce. So that means we do have to we need a somewhat different paradigm. And the paradigm, we feel is back to the future. It's nature, right? The only thing is to help nature do it a lot better and a lot faster. Because nature will do it ultimately. It's just we won't like the answer probably because it won't likely include human beings.
Yeah.
It is interesting, So if you accept the fact that I'll say helping nature solve the problem is the right way to go, then that means we also have to, as a people, get our heads around that too, right? So let me give you some examples. the world is heading towards mega cities where probably 60% of the people will live in mega cities, like huge cities. Those cities will generate enormous waste problems, right? So if you don't create kind of the circular economy mindset where everything that is being done is being essentially processed and reprocessed and processed again into, food and materials, energy, chemicals, all the things we need, then we're simply going to collapse in on ourselves. So the real driving force behind our company is to avoid that end state. That means billion-ton solutions, right? Yeah. So the world produces, depending on who you talk to, but say roughly 50 billion tons of CO2 equivalent a year. And so that means solutions have to really be in the billion-ton a year deployable space.
Yeah.
And that's really tough, but it does mean thinking about, what some people think about food and, the 50-mile radius of getting your food and so on. If you think about these mega cities and sort of a 100-kilometer radius of self-sufficiency, if I could put it that way, that's the mindset that you ultimately want to have, right?
Yeah.
So if we think about that, what's that mean? Well, we've got a refining center in the east side of Edmonton. If we had a biorefining center like that as a model for the rest of the world, and we have the wherewithal to do that if we chose to, it would be supporting our agricultural industry with fertilizers. It would be supporting our food needs with all kinds of ingredients and amino acids and different things. It would be supporting our materials. It would be supporting our chemicals for, make our things, like your perfume or your whatever, right?
Yeah.
And it would be doing all of this in an integrated basis. And at the end of the day, just like we're saying with nature, would balance out. Now, maybe not exactly in every community, but collectively it would. So our goal is we want to do that, and our first agenda is sustainable aviation fuel. That's our long-term goal. Because aviation isn't going to change to batteries because they're too heavy, right? So it's going to burn something.
Yeah.
And so how can we make them something that's clean and essentially cycles their emissions at the same rate that they're being consumed and back into the fuel they need, in more or less, right? That's the mindset. To do that, we're talking about 1 billion or 2 tons equivalent a year. And that means, as I say, it's refinery scale stuff like we've got here, but it's probably 50 of them around the world. And as I say, as a longstanding Edmontonian, I'd love to see that kind of thinking emerge and get established here and see the rest of the world coming to us to get it.
You say we have the wherewithal to do this. And if we do have the wherewithal to do this, how come we haven't done it yet? Where there's our roadblocks that are preventing us from moving forward?
There are 2 or 3 things. First of all, it takes a bit of patience. It's hard sometimes for politicians to have the patience that it takes, but it does take patience. It's different than pushing a button on an app, and now I copy it 1 billion times, right? This actually, I have to build things, and that actually takes some time, and it takes a lot more money. So they need to help build, if you like, what we would call the bridge over the valley of death, which is where you've got your sort of workable kind of what they call minimum viable product, but you've got to get to the other side where you've scaled it enough that people can say, oh yeah, we can now go into the big leagues. And that does take help from the public sector. So that's one thing. It does take this vision, and I'll remind people that it's actually that vision that brought the oil sands to where they are today. It took a long time. It took from about the 1920s to the 1960s, right? And we're in that kind of a mindset here. We're in the early days. Digital will help us do it faster, which is nice, as we've already shown. So probably by kind of the 2035 stage, we could envisage these things starting to appear, right, and grow up around the world. But it still takes that. and it's going to take a little bit of financial support along the way as well, right? Otherwise, think of Edmonton as the perfect place, right? Because we're in the center of a skill set that understands manufacturing and processing on a grand scale. We have the support industries. We have universities that produce the right kind of people. We've got the industries that can be an anchor to become sort of users and benefiters from what's done. So we're likely to keep it here. Scott, you couldn't ask actually for a much better place.
Yeah, even when we talk about biomanufacturing, like with the molecule that you guys work with, we have a biomanufacturing capacity here, as we see with the Canadian critical drug initiatives. That's one aspect of biomanufacturing, but we do have presence.
We do have some examples for sure, right? But it's a very nascent industry in Canada on the non-health side. And, the challenge, of course, is on the health side, they need, it's a terrible thing to say, but to a large degree, they're wealth consumers at the end of the day. And it doesn't mean that people can't make money doing it, but that is the way it works. Whereas what we've got to make sure is we've got also the wealth producing side, which is that's where you get into manufacturing and product making. That is, you can sell and export on a much grander scale. The biggest challenge in this space is that again, I'll go back to Alberta. We're a commodity-minded place, whether it's ag or energy or chemicals. That's the space ultimately we've got to get into. That's hard. It's, but we're at the point where it is feasible. And we look at things and recommendations from very knowledgeable people, like the National Academy of Science in the U.S. and so on, who talk about the kinds of productivity, the pace of development, all the kinds of things that we're dealing with that should be achievable. And, we're right on the forefront of that. So that gives us a lot of optimism that this could be a real game changer.
Anything else that you'd like to add that I maybe missed?
Well, we're raising money.
Perfect.
At the moment, actually, we're literally there. We've got our first designer organism alive and kicking, and we're ready to push it down the scale route. So it's going to take us about $2 million to do that, and then we get to build a real factory. But we're right in the early days of that, and we hope that we'll find people who share our vision and really want to be part of this transformed economy.
Wonderful. Yeah, well, thank you so much for joining us.
Well, thank you.
It's been really insightful, and I'm really happy that we had you on.
Well, thank you very much.
Thank you so much.
No.
Thanks for listening. Stay tuned for our next episode of Decarbonizing Today, where we meet with the Alexander Business Council to continue exploring how decarbonizing tomorrow starts today in the Edmonton Metro region.